The MRAM, or the Magnetoresistive Random Access Memory, is one of the most promising types of non-volatile memory for computers. Unlike the other types of RAM, the data in the MRAM chips is stored as magnetic storage elements rather than as electric charges. The elements are formed from two ferromagnetic plates separated by a thin insulating layer. Each of the plates can hold a magnetic field element. One of the two plates is a permanent magnet set to a particular polarity, while the other's field can be changed by exposure to the external field in order to store memory. This configuration is known as a spin valve and is the simplest structure for an MRAM bit. A memory device is built from a grid of such cells. The simplest method of reading is accomplished by measuring the electrical resistance of the cell. Each cell is associated with a transistor that switches current from a supply line through the cell to ground. Due to the magnetic tunnel effect, the electrical resistance of the cell changes is associated with the orientation of the fields in the two plates. By measuring the resultant current, we can determine the resistance inside any particular cell and the polarity of the writable plate. Typically, if the two plates have the same polarity, this corresponds to the logical one, while if the two plates are of opposite polarity, this would be the logical zero. MRAM has performance similar to that of SRAM and density similar to that of DRAM, but is characterized by much lower power consumption than the DRAM. It is also much faster and suffers no degradation over time in comparison to the flash memory. It is this combination of features that, as some suggest, makes it the universal memory that is able to replace SRAM, DRAM, EEPROM, and flash. This also explains the huge amount of research being carried out for the purpose of its further development. However, to date, MRAM has not been too popular in the market.